Hello, so today we'll be doing AP problem number 9. So it says that the graph below shows the result of the titration of a 25 milliliter sample of a 0.1 molarity solution of weak acid HA with strong base 0.1 molarity and NaOH. So I drew my graph there, and the first question, part A, asks, describe two features of the graph above that identify HA as a weak acid. So if you take a look at the graph, you can see that the initial pH is greater than 1, which helps us identify that, and also that the pH of the equivalence point is greater than 7. Okay, moving on to part B. Describe one method by which the value of the acid dissociation constant for HA can be determined using the graph above. So you can find Ka by using 10 to the negative pH to determine Ka at the half equivalence point, and you just get the pH by actually just looking at the graph and lining it up. Where the half equivalence point is, you'll be able to see the pH on the y-axis. Part C. On the graph above, sketch the titration curve that would result if 25 milliliters of 0.1 molarity HCl were used instead of 0.1 molarity HA. So you know that the initial pH would be 1, and then that the pH at the equivalence point is 7 at 25 milliliters, because a strong base and a strong acid, when they reach their equivalence point, will be a neutral solution. And you know that the titration point after the equivalence point is basically the same as the original curve, as I drew on that graph below. Part D. A 25 milliliter sample of 0.1 molarity HA is titrated with 0.2 molarity NaOH. Part I. What volume of base must be added to reach the equivalence point? So I use the volume times molarity is equal to millimoles. So I multiplied 25 milliliters times the 0.1 molarity of HA solution, and I got 2.5 millimoles of HA. Then you know that they're going to have equal amounts, so I concluded that there is 2.5 millimoles of OH minus as well. So then I divided the 2.5 millimoles of OH minus by the 0.2 millimoles over milliliters, or molarity, and then I got 13 milliliters, which would be the volume of the base that needed to be added to reach the equivalence point. Then for part 2 it asks, the pH at the equivalence point for this titration is slightly higher than the pH at the equivalence point in the titration using 0.1 molarity NaOH. Explain. Okay, so here you know that the total volume at the equivalence point is 50 milliliters with the 0.1 molarity NaOH. And with the higher concentration of 0.2 molarity NaOH, the equivalence point volume is going to be 37.5 milliliters. So this signifies that the A minus, which is the molar concentration of the conjugate base HA, is going to be larger than the A minus with the 0.1 molarity NaOH. So this means that the pH will just be a tad higher.